Before we can use the plasma cutter, we have to make sure that our shop area is safe and clean. There's no obstructions where we're working so we don't trip and hurt ourselves. Next, we want to make sure we have the proper PPE. So we want to make sure that we're wearing gloves. We need to have long sleeve shirts on to cover our hands and any exposed skin from UV rays and hot molten metal. We're going to adjust our helmet. We have delay time, sensitivity, and shade. Shade and sensitivity need to be set all the way up, and delay time you can adjust as you're welding or plasma cutting. On the helmet here, the Lincoln helmet, we have dials on the side to adjust how fast the helmet will flip up and down, and then Lance will show us the dial on the back that we will use to adjust the size of the helmet for different shaped heads. Now that we're all dressed up and ready to go, we better start up here. So we're going to make sure our machine's plugged in to 220 volt. Then we're going to turn on the oxygen levels all the way open to our valve to feed the gun with oxygen so we can cut. Then we're going to go over to the machine and fire it up, and we'll set it around the 40-45 mark, which is a high setting to cut first. Next, we're going to learn how to use the gun. As you can see, there is a safety. We can't flip that up and compress the trigger until the safety is turned off. Right now, green means go, so the safety is off. Yellow means the safety is on and the gun will not be able to fire. Lance turns the safety off, and now he's able to flip up the safety and compress the trigger. As you can see, green is go. Now we're going to learn how to hold the gun. Lance got braced on his left arm underneath. He's right-handed, so he'll hold the gun in his right hand. He will start at an aggressive angle, and then as he compresses the trigger and he starts cutting, he will roll his wrist over and keep that base in a steady position. We're going to show you an example of what happens when you set the machine too low on the power setting. The sparks do not go to the bottom, they spread all over the place because there isn't enough power and heat in order to cut through the metal. You'll notice that Lance is grounded on the piece he's cutting. That enables the current to flow through the metal and cut. Doesn't go through. Readjust the temperature up for us to be able to cut through the metal. Now the gun height is another important thing we have to address. In this example, the gun's too high, and you can see that it doesn't like to keep the current. Cuts in and out. This is an example of the gun being too close. You'll see a huge pile of metal pool at the bottom of the cut piece. That is not a clean cut, and that is not what you want. Another problem is it gunks up the end of the gun. See that piece hanging there? And it splatters all over. And there's the tip starting to plug Here's the correct angle. Notice him roll over the top. He starts off on a 45 and then reduces that angle somewhere around 20 degrees. Gives you a nice, clean cut. Speed is another important factor we have to take into consideration. Okay. In this example, Lance is going too fast. In this example, we're going to show Lance here going too slow. It takes a long time to cut through the metal, which is a major problem for us because time is money in the trades. And if you're taking too much time to get things done, you're not going to have a job for too long. Also, you'll notice that there's a lot of molten metal that is accumulating on the bottom, and that's something you don't want for pieces you're cutting as well. Did I mention how long it takes to cut through? One thing we need to make sure we're doing is pushing away from ourselves at all times. Okay, this is the proper speed and also the right technique on pushing away from our bodies. You'll notice that there is not a lot of molten metal pooling in front. It's cutting through and going out the bottom, which helps keep your cuts clean. The cleaner your cut, the less grinding you have to do later on. Again, time is money. Here's an example of Lance pulling it towards himself. It's really hard to keep the right angle. It's very hard to have a consistent speed when you're pulling towards yourself, not to mention the safety factor involved in pulling a hot gun towards your body. This is a no-no, and something you want to watch out for when you're teaching this to students. Great cut though, just improper technique. This is the proper technique. Watch him roll the gun over the top, pushing away from his body, keeping everything safe. Angle of gun is another major factor you want to look for when you're teaching this to students. You want to make sure that the gun starts off with a nice 45-degree angle and then roll over the top. As you can see here, Lance is not rolling back over the top, and therefore the angle is too great. You can see the molten metal pushing itself down the top of the sheet. That is not what you want to have happen. Watch him roll the gun now over the top as he continues with his cut, reducing the angle and therefore making sure that the molten metal pushes to the bottom and you get a nice clean cut this way. Less grinding, less time, more money, keeping a job. Now our pieces are going to be incredibly hot that we're using, so what we need to make sure we're doing is we're cooling the metal off, and we should be labeling everything with chalk and writing hot on it as well, just to alert those around us from not touching something that they can really hurt themselves on. Once the metal's cool, we're going to break off any pieces that we have left that are still attached, and then we're going to take this over to the grinder. We want to make sure we wear our safety glasses so we don't get any pieces in our eyes. we're going to put our gloves back on as well. As you can see, the piece of metal has some very rough edges, so we want to smooth those edges out and make it look as clean and aesthetically pleasing as possible. Lance will grind back and forth, not staying in one spot too long and therefore melting his way into that piece. He just wants to smooth it out, not change the outcome or the look of the piece. And now it's nice and smoothed out. That's a finished product. Nice little cat we did. Very, very smooth corners. No one's going to hurt themselves on those. And now that our project's done, we need to make sure that we shut down the shop and clean everything up properly. We're going to unclick our ground cable, turn off our machine. We're going to also turn off the oxygen to make sure that that's not pumping anymore, because that also costs money if we run out of that. And then what we want to do is we want to ensure that the work area is clean. We left it in a better place than we did before we got there, so anyone else that's working is safe and in a nice, clean environment.